Okay, so this is the second video for 1-3 notes. We're going to focus on experiments. So what you should learn is to distinguish between an observational study and an experiment, explain the concept of confounding and how it limits the ability to make cause and effect conclusions, identify the experimental units, explanatory and response variables, and treatments in an experiment, explain the purpose of comparison, random assignment, control, and replication in an experiment. Describe a completely randomized design for an experiment, including how to randomly assign treatments using slips of paper, technology, or a table of random digits. Describe the placebo effect and the purpose of blinding in an experiment. Interpret the meaning of a statistically significant in the context of the experiment, and explain the purpose of blocking in an experiment. Describe a randomized block design or a matched pair design for an experiment. So we are going to focus on the AP Topics 2, sampling and experimentation, specifically for experiments and observations. Again, this is 10 to 15% of the test. And we are going to use the state, plan, do, and conclude method for answering our questions. Remember, the statistics problems demand consistencies, and so does our answers. So we have already talked about a survey. Surveys are an investigation of one or more characteristics of a population. Now we are going to talk about experiments. Experiments happen when you deliberately impose some treatment on individuals to measure their response. We're also going to look at observational study, which observes individuals and measures variables of interest, but does not attempt to influence the responses. So experiment makes a change to the environment or the individual. Observation simply watches. The fourth way that you could do data collection is called simulation, and that is the use of mathematical or physical models to represent the conditions of a situation or process, especially when that process is too dangerous or expensive to be done as an experiment, such as Okay, observational studies versus an experiment. You need to know that there is a response variable which measures the outcome of the study. That is what you're looking for as a result of the study or the experiment. The explanatory variable is what explains or predicts changes in the response of the variable. You could lose credit on an AP exam for using statistical vocabulary without additional explanation. Instead of relying on the vocabulary, you should explain the concept in the context of the problem. Confounding variables occur when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. Some people call a variable that results in confounding, like the number of doctor visits per year in a case, a confounding variable. Observational studies of the effect of an explanatory variable on a response variable often fail because of the confounding between the explanatory variable and one or more of the other variables. If you are asked to identify a possible confounding variable in a given setting, you are expected to explain how the variable you choose is associated with the explanatory variable and affects the response variable. So here's our first check your understanding. So for this description, was it an observational study or an experiment, and why? So this one describes an experiment because the treatment of brightness of screen was imposed on the laptops. Okay, so this ABC News article describes a situation. Was this an observational study or an experiment? What are the explanatory and response variables? And explain clearly why such a study cannot establish cause and effect relationship. Suggest a variable that may be confounded with whether families eat dinner together. So this is an observational study. The explanatory is the number of meals per week eaten with their family. So that's how much that's the measurements that you're doing. That's your explanatory. The responses is GPA. So did their GPA go up or down based on how many meals they had with their family? That's the idea that we're looking for. And then finally, there are probably other variables that influence the response variables, such as having a part-time job or not having enough time to study. So language of experiments, words that we need to be very familiar with when it comes to experiments is, first of all, treatment, a specific condition applied to the individuals in the experiment. In an experiment, if an experiment has several explanatory variables, a treatment is combined of the specific values of these variables. Experimental units is the smallest collection of individuals to which the treatments are applied. Subjects, when the experimental units are human beings, we are referred to as subjects. And factors, the explanatory variables in an experiment, organized by layers in multi-factor experiments. Okay, so here's an example, and again, these examples are for you to see how your answers should be worded when you're doing assignments. You want to identify the experimental units, explanatory and response variables, and the treatments and the experiment. So the solution is the experimental units are the 376 households, not the 812 people. They applied the medicine to the entire household. They just contained 812 people in total. So the household is the experimental units, because the treatments were assigned to entire households, not separately to the individual people. The explanatory variable is which type of medication they used, and the response is whether or not the household was lice-free. So principles of experimental design. The basic principles for designing experiments are as follows. First of all, comparison. Use a design that compares two or more treatments. Random assignment. Use chance to assign experimental units to treatments. Doing so helps create roughly equivalent groups of experimental units by balancing the effects of other variables among the treatment groups. Control. Keep other variables that might affect the response the same for all groups. And replication, use enough experimental units in each group so that any differences in the effects of the treatments can be distinguished from chance differences between the groups. And statistics replication means use enough subjects. In other fields, the term replication has a different meaning. When one experiment is conducted and then the same or a similar experiment is independently conducted in a different location by different investigators, this is known as a replication. That is, replication means repeatability. So you could lose credit on the AP exam for failing to adequately describe how you assigned the treatments to experimental units in a experiment. And most importantly, the method must be random. You could lose credit for failing to adequately describe how you assign the treatments to experimental units in an experiment. So here's an example of a problem. This kind of was pulled from the textbook, so you won't see the actual experiment described, but we are just interested in how do we assign the 15 students to each of the two groups. And we want to explain it using 30 identical slips of paper, using technology, and using Table D. So I won't read this all out to you, but please note how detailed they are. Think of it this way. Whenever you're doing these kind of problems, you're wanting to describe it in a way that someone else could repeat it. Try to write it in a way that maybe a third grader would be able to follow the steps. Explain how each of the 4 principles of experimental design was used in this multitasking study. So again, those 4 principles are comparison, random, assignment, control, and replication. And again, please read through this and see how detailed your answer needs to be. So completely random designs. In a completely random design, the experimental units are assigned to treatments completely by chance. So your first step would be you take your group of 50 volunteer students. You would use the technology, the table D, or the slips of paper to randomly choose your first group of 25. The remainder of the group, that 50 student volunteers, would be in group 2. Then you would assign group 1 of the treatments, and group 2 the second treatment, in this case online versus classroom. And then at the end of the experiment, you would compare the results on the campus scores, SAT scores. So if you are asked to describe the design of an experiment, you won't get full credit for just showing a design. You need to be able to describe how the treatments are assigned to the experimental units and to clearly state what will be measured or compared, just like I did as I was talking through the design. So if you're trying to get an idea of how to word it, talk yourself through the design. Use the design as a talking point. That way you can see, I used this method, I grouped it in this way, I assigned it in this way, and I compared the data in this way. That is how you would want to write it out. Okay, so here's another example, and we want to describe a completely randomized design for this experiment and write a few sentences describing how you would implement the design. So here's what the design would look like. And again, writing this out would help you to be able to get a wording of how you'd want to do it. You have 60 children, you randomly assign. In this case, the example shows you using slips of paper. You could have used the table D option, or you could have used the RandInt technology option. Whatever method you use, make sure you detail that part of the information. We randomly assign the first 20 people to the group 1, second 20 people that are selected to group 2, third group to 3. They use the idea of using slips of paper and numbering the slips of paper 1, 2, and 3, and randomly picking from the hat, and each child is assigned whatever number that was chosen. Then you would assign treatment 1, treatment 2, and treatment 3 to their representative groups, and then you would compare the mental ability and impulse control, excuse me. So here's it, check your understanding. Again, I want you to do this. I want you to describe a completely randomized design for this experiment and write a few sentences describing how you would implement your design and what is the purpose of the control group in this experiment. So randomly assigning 29 students to 2 treatments, evaluating the performance in small groups, or evaluating the performance alone. So that is your, though the performance is going to be your explanatory variables. The response variable will be accuracy in their final performance evaluations. To implement the design, use 29 equally sized slips of paper, keywords, and must say equally sized. Label 15 of them small group, 14 of them alone. Then shuffle the papers and hand them out at random to the 29 students to assign them to a treatment. The purpose of the control group is to provide a baseline for comparison. Without a group to compare to, it is impossible to determine if the small group treatment is more effective than doing it alone. So experiments, what could go wrong? When subjects respond favorably to any treatment, even a placebo, the response to the dummy treatment is called the placebo effect. Whenever possible, experiments with human subjects should be double-blind. In a double-blind experiment, neither the subjects nor those who interact with them and measure the response variable know which treatment a subject received. Reports in medical journals regularly begin with the words like these: from a study of a flu vaccine given as a nose spray, quote unquote, this study was randomized, double-blind, placebo-controlled trial. Participants were enrolled from 13 sites across the continental US between mid-September and mid-November. Doctors are supposed to know what this means. Now you know too. You might believe that an experiment cannot be double-blind because someone has to know who gets which treatment. Although there is always someone who does know which treatments are received with or which subjects are receiving which treatment, as long as this person doesn't interact with the subjects or measure the response, the experiment can still be double-blind. So check your understanding. Did the experimental design take the placebo effect into account? Why is this important? Was this experiment double-blind, and why is that important? And how could you improve the design? So no, the experiment was not, the unborn child, the mother knew ahead of time that they had the ultrasound and maybe ate healthier for their baby, resulting in healthier children. That it is not a double blind because, again, some of the mothers knew that they had it and some of the ultrasound and some did not. And then finally, if you wanted to make it a double blind, you would have to treat all of the mothers as if they had had an ultrasound. But for some of the mothers, the ultrasound machine would have been turned off. And to prevent the mothers from figuring it out, you would have to turn the ultrasound screen away from the mothers and possibly even have background noise. So inference for your experiments, and an observed effect so large that it would rarely occur by chance is called statistically significant. Although a statistically significant association in data from a well-designed experiment does imply causation, a statistically significant association in data from an observational study does not imply causation as well. The design of the study is what determines if a cause and effect conclusion is possible. Okay, so there are two ways that we can do some experiments. One of them is called blocking. A block is a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the response to the treatments. So for instance, grouping by male and female, because sometimes medications um, have different reactions based on sex. An example here would be you have 10 volunteers. Some of them are smartphone users, some of them are not smartphone users. You would group them based on that, not randomly yet. After they are grouped into those two groups, then you do the random assignments into their testing groups, the keyboard A, B, C, and D. Then you would compare their typing speeds in each one of those groups within the smartphone group, and then you would compare them in the non-smartphone groups. And then you would compare those two big groups to each other and combine the results. In a randomized block design, the random assignment of experimental units to treatments is carried out separately within each block. And a matched pairs design is a special case of a randomized block design that uses blocks of size 2. So here's an example, microwave popcorn. Explain why a randomized block design might be preferable to a completely randomized design for this experiment. Outline a randomized block design for this experiment and describe how you would carry out the random assignment required by your design. So again, this is meant to give you an idea of what to look for, what they're looking for answers. I'm not going to read these out to you. You can read them yourself. Okay, guidelines for designing a statistical study. So once you've decided you're going to do a statistical study, what do you do? These are the steps. First of all, identify the variables of interest, the focus of your study, and the population of the study. Next, develop a detailed plan for collecting the data, such as the ones we've discussed. If you use a sample, make sure that the sample is representative of the population and randomized. Then you would collect your data. After you've collected your data, you want to describe the data using descriptive statistical techniques, such as finding the mean, the median, the mode, the standard deviation, and those kind of things, which we will look at during Unit 2. Next, you're going to interpret the data and make decisions about the population using inferential statistics. So once you've grabbed some data, you've done some calculations with it, now you're going to interpret the data to decide Is what you were expecting, is the variables of interest, is there a significant, statistically significant reason for causation that could be applied to the population as a whole? And then most important is you want to identify any possible errors. Errors occur because there are different ways that you may have collected data bad. Your survey or your observations or your experiment may have had a bias. You may have not had a randomized group. So there are errors that you need to identify. That way you can address anybody that is repeating the experiment, observation, etc., can overcome those errors.